Good evening, dear friends. Hoping that you are fine and preparing for your external exams of IGCSE physics with a lot of concentration towards studies and hard work. Today, we are solving paper 4 variant 3, October-November 2021. If you think that this recording is going to be helpful for you, so please don't forget to like this, follow this channel, and share this with your friends, especially who are going to take the external exam this year in May, June, or in October, November. And also subscribe to the channel if you have not subscribed yet. And let's start the paper. There are some tricky one things that we'll be discussing, and let's continue it. A ship sails in straight line between two ports. Figure shows the speed time graph of the ship for the first 100 minutes of its journey between the two ports. Now it is a speed time graph. This is okay, no problem at all here. Meters per second is the unit. But here, time is in minutes. That we need to convert wherever we are using this time, it must be converted to seconds. Okay. So calculate the maximum acceleration during the first 100 minutes of the ship's journey. Now, if we talk about this graph, this portion of the graph shows acceleration is equal to 0 because the velocity change is 0, velocity is constant. If we see in the beginning, the acceleration is increasing slowly because slope is increasing slowly. We will choose the point like I'm choosing from here till here. This is the position where the gradient of this graph is maximum. So we will find the gradient of this graph, which is equal to acceleration, because speed time graph, gradient of speed time graph is always giving us acceleration. So let's start it. See, this is starting time. And if you ask me one small square along time axis that is equal to 20 minus 0 over 10, it means each small square is equal to 2 minutes. And similarly, one small square along y-axis that is equal to 5 minus 0, the difference of the numerical values consecutively marked on y-axis over the number of divisions which are 10. So each small square that is equal to 0.5 meters per second. Always find this resolution of the graph on x-axis as well as on the y-axis. You can also call it least count. Now, of course, this is 40, 38, so it means this is 36. And this one is 60. So this one will give us, this interval will give us the time. Now u, initial velocity is 5, final velocity is 15, and easily we can calculate the answer. A is equal to V minus U over T, or gradient of the graph. V is equal to 15, U is equal to 5 over time, which is 60 minus 36, but be very careful, times 60 to convert it from minutes to seconds. And as I'm simplifying it, I will be writing the rounded off answers. As I'm simplifying it, I'm getting the answer equal to 0.00 0.069. The answer here is 0.0069. 0.0069, and even we can write it in the standard form 6.9 times 10 raised to power 1, 2, and 3. So minus 3, and don't forget to write the unit meters per second here. Next, calculate the total distance traveled by the ship between 42 minutes and 100 minutes. Speed time graph, the area under the speed time graph is equal to the distance traveled always. So let's see it. So area under the graph. See, I will be drawing a diagram for you people. See, I will do it in two portions. First of all, this is A1 and this is A2. A1 is a trapezium and A2 is a rectangle. So I will be using this one now. For trapezium, see this. Okay, first of all, let me write B is equal to 1 over 2 times A plus B times H plus. So A plus B is basically the sum of parallel sides of the trapezium times H, which is the distance between the parallel sides, plus length times width, because the B or A2 is a rectangle. Now let's mark the numerical values which are needed. My dear friends, this is the difference H between two sides. That is 60 minus 36. So we can write 60 minus 36 equal to 24. So this is 24. A is equal to 5 and B is equal to 15. You can check it here. H is also with us. Similarly, for this rectangle, one side is 15, the other side is 100 minus 60, so that is equal to 40 minutes. Now we will start solving. So it is equal to 1 over 2 times A, which is 5, plus B, which is 15, times H, which one is 24. But here again you need to wake up. 24 times 60. We cannot use in minutes, because we will be writing the system international unit for time, which is seconds, plus length, let it be 15 times 40, but again 40 minutes, so 40 times 60, it will be converted to seconds. So when we are solving it, we are getting the answer we are getting it 14,000. Just a minute. These values, this is 5. Okay. So these values, this answer is 14,400. So here, this one is 14,400 plus 15 times 100. Oh, not 100. 15 times 2,400. That is 36,000. Now, it looks to me we are doing some mistake here. Wait a minute. So this is 60 and 20. This is 30, 32, 34, 36. And here U is equal to 5. And V is equal to 15. So A and B, this is equal to 15. So my dear friends, here, So 5 plus 15, A plus B, so 10. So times 24, so 240 times 60. 240 times 60. 24. Yes, this is 24. So 24, just let me confirm, 24 times 60 equal to this. So times 10. Yeah, made some mistake. Let me check in the diagram. So we have chosen this portion. Wait a minute. I am doing one mistake from 42 minutes to 100. That's what was the mistake. So here, see, it is from 42 minutes. 42 minutes. And what we have done, we have done taken it from here. No, that's for acceleration. So 42 minutes starting from here. So see, this is 5, 6, 7, and this value is 7.5. So here, my dear friends, we will be changing it from 5 to 7.5. And then here also it will be no more 24. It will be 18 because 60 minus 40 that's 18. Now let's calculate. So it will be now C 15 plus 7.5 equal to 22.5 divided by 2. We are getting 7.25 times 18 equal to this times 60, that is equal. Now it is correct. So 12,150. This numerical value is 12,150. And as we will add them up together, plus 36,000, answer is equal to 48,150. So we can round it off to 48,000. Even you can write 48 kilometers. So that will be for 3 marks. And be very careful. The time is in minutes. For the correct values, you are supposed to convert from minutes to seconds. And that's what we did here as well as here. Now, this is very simple. Now, at a time not shown on the graph, the acceleration of the ship is this. The total mass of the ship and the passengers is this. Calculate the resultant force on the ship. Very simple question. F is equal to MA. Mass 2.3 times 10 raised to power 7 times 0.0087. So when we are simplifying it, 2, 3, and then 1, 2, 3, 4, 5, 6 times 0.0087, we are getting 200. 100. So simply we can write 2.0 times 10 raised to power 1, 2, 3, 4, 5 newtons. Explain why the force on the ship due to ship's engine is greater than the value you calculated in C1. It is due to resistive force, which you can also call the drag force. Resistive force of water on the ship. Okay, dear friends, let's move forward. Question number 2, that is also a good question. Figure shows the simplified version of a gravity lamp. This apparatus is used to light a light emitting diode without the mains electricity. LED is the generator is there, and this whole system is attached to the ceiling. Strap are there, and 12 kilogram load is there, which is pulling this strap downward. The load of 12 kilogram. Now, don't think that this is weight. Mass is measured in kilograms, so actually this is 12 kilogram mass of the load. Raised to a height of 1.7 meters above the ground, the load is connected to a pulley system. The time taken for the load to fall to the ground is 1200 seconds. The load falls at constant speed. The generator is connected to the LED. Calculate the rate of gravitational potential energy as the load falls to the ground. Now, rate of transfer of energy, it is equal to power, because the definition for power is rate of doing work or rate of transferring energy. And in IGCSE physics, whenever we are using the term rate, it means the time is involved into the equation, and that is in the denominator. So, dear friends, power is equal to energy over time. And in this scenario, it is mgh over time. All the data is with us. Mass is 12 kilogram. Value of G, we will use 9.8, no more 10. And height is 1.7 over 1200. And as we are simplifying, answer comes to be 0.166. So we can write it 0.17, and it is rate of transferring energy, so you can call it watt. Then, my dear friend, the light output of the LED is 0.10 watt. It is 0.10 watt. So output power is 0.10 watt. So calculate the efficiency of the gravity lamp. Very simple. We will use the formula of efficiency is equal to useful output power in this case. If the energies were given, then useful output energy over total input energy. But in this case, powers are there, so useful output power over total input power. And also, as a tip, let me say that in the calculation of efficiency, the numerator numerical value is always smaller than the denominator's numerical value. So this is equal to now 0.10 watt over 0.17 watt times 100%, and it comes to be 58.8% roughly, and we can write round it off to 59%. Suggests a social or environmental advantage of using a gravity lamp. Social or environmental advantage of gravity lamp. Very simple. No fossil fuels are used to light up LED. So, no greenhouse gases released to the atmosphere, to the environment even. So in this way, this is having a good advantage. When the fossil fuels will be used to boil water, to turn it into steam, to turn on the turbine, and ultimately to turn the coil of the generator. So of course, burning fossil fuels means greenhouse gases are released to the atmosphere, causing the environmental pollution. In this case, no fossil fuels are used up. So that is a beneficial, some sort of positive approach. Now, this question is also very tricky, especially the part two. A gas bubble is released at the bottom of a lake. The atmospheric pressure is this. The density of water is this, 1000 kilogram per meter cube. It means this is fresh water because the density of seawater is higher than 1000 kilogram per meter cube. Temperature of the water in the lake is constant. So it means one way or the other way we are going to use Boyle's law. P1 V1 is equal to P2 V2. The gas bubble rises to the surface. It means the volume of the gas bubble will increase as the pressure on it will decrease. So the volume of the gas bubble increases as it rises higher the water. Describe why the volume of the bubble increases. As I told you, Boyle's law will be in action here. So, as I told you in the beginning, so volume is inversely proportional to pressure and the temperature is kept constant. Sorry. Now, as the bubble rises up, the pressure on it decreases. Which pressure? Pressure of water on it decreases due to water. So volume of bubble increases. Answer is done. But I just want to share one thing over here. See, my dear friends, when the bubble was at the bottom of the lake, more water molecules above it. More molecules, so more mass. More mass means more weight or force. And pressure is directly proportional to force. At the bottom of the lake, there is a greater pressure on the air bubble, and as a result, its volume is less. But as it rises up, the number of water molecules above it are decreased. So mass is decreased. It means force or weight of the water on the air bubble is decreased. So it will expand. In other words, the volume of the bubble will increase. Now this one is really tricky, 4 marks. The volume of the gas bubble is 0.40 centimeter cube when it is 3 meters below the surface of the lake. Calculate the volume of the gas bubble when it is 0.5 meters below the surface of lake. In other words, it rises up. Before starting the question, we are going to use here Boyle's law. P1 V1 is equal to P2 V2. We need to find V2. But as the atmospheric pressure is given, so it means the total pressure on the bubble will be the pressure of the atmosphere on the surface of the water plus the pressure of the liquid. So these two pressures are actually added up as the pressure on the air bubble into the water. So that's what I'm going to do right now. So be very attentive. CP1, 1.0 times 10 to the power 5 plus pressure in liquids is rho GH, density times G times depth. So 1000 times 9.8 and the depth in the beginning that is 3 times V1 which is 0.40. This is equal to P2. Again, the pressure of the atmosphere is there, which is 1.0 times 10 raised to power 5 plus rho gh. 1000 is density, 9.8 is the value of G, times the depth is now 0.5 times V2, which we need to find out. I have done it, of course, and when we are applying these calculations, we are getting the final value of V equal to the 0.50. So answer is rounded off answer, estimated answer is 0.50 centimeter cube, but this you have to be very careful. Atmospheric pressure, you are supposed to add up with the pressure of the liquid. So total pressure of the air bubble, wherever it is in the water, it is the pressure of the air plus the pressure of the water on the air bubble. Inside the water below, mean the air bubble below the water in the lake. Now, figure 3 shows a diagram of hydraulic press used to compress paper for recycling. When a force is applied to piston A, it causes a pressure in the oil. This pressure produces an upward force on the piston B, and the piston B moves, it compresses the paper. So here force is applied downward, it pushes the oil, and oil is applying a force upward on piston B, and paper is compressed. A small quantity of air leaks into the oil. Suggest and explain the effect of the air has on the operation of the hydraulic press. Now, paper being a solid, paper will not be compressed. Paper will not be compressed too much because some of the energy is used to compress the air instead of paper. So like this you can say, so it affects the efficiency of the hydraulic press. What it? I mean the air which leaks into the oil. Next, my dear friend. Explain what happens to the pressure of a constant volume of air. So in this explanation, you are not going to use that molecules are getting closer together or they are moving further apart. No chance, because the volume of the air is constant. When the temperature of the air increases, use ideas of momentum of molecules in your explanation. Ideas of momentum of molecules in your explanation. So you can say molecules of air gain kinetic energy and hit the walls of the container. Now I'm using shortcut for molecules MOL. Molecules of air hit and rebound such that in terms of momentum, such that momentum of molecules momentum of molecules is changed. How momentum of the molecules is changed? Container, let's suppose gas molecule hit the wall of the container with velocity u, then rebound. So it goes back with velocity v. Momentum is the product of mass and velocity. So if the direction of the velocity is changed, it means the momentum is changed. This is 2 marks, whatever we have written. Now, I'm writing one equation from Newton's second law of motion. Even you can write this theoretically, numerically, as the form of an equation. F is equal to rate of change of momentum. So when the momentum will be changed, it means force is exerted. And we know pressure is equal to force per unit area. This will be 1 mark, this will be 1 mark, and this one will give you 2 marks. So 2 plus 1, 3 plus 1, 4. So definitely molecules will gain kinetic energy and they will hit the walls of the container. So molecules of air hit and rebound such that momentum of the molecules is changed. And rate of change of momentum is equal to force. And what is pressure? Pressure is force over area. Hit, and here you can say hit hard and rebound such that momentum of the molecules is changed. So F is equal to mv minus mu over t, and for greater force exerted on the walls of container, pressure of the gas will be increased. And you can write this equation also, pressure is equal to force over area. So in this way, you will score all 4 marks. Okay, my dear friends. So this is done. Now let's move to another question. An aluminium saucepan and steel saucepan have the same dimensions. So it means their volume is same. Volume is same. Table 5.1 shows the values of the specific heat capacity and the density of aluminium of the steel. Metal name aluminium, specific heat capacity 0.91, for steel 0.50, and their densities are also given. The mass of the aluminium is 0.41 kilogram. Calculate the mass of the steel saucepan. Mass of the steel saucepan. So we can go with the ratio method. Why? See, density is equal to mass over volume. So this implies that density is directly proportional to mass. Why? Because volume is constant. So mass of steel will be equal to 0.41 times 7600 over 2600. If you will check it out, answer, we are just using this method, 0.41 times 7600 times 7600. This one divided by 2600, we are getting 1.19. So we can round it off to 1.20 kilogram. So just the ratio method, as the density is directly proportional to mass. So mass of density of the steel is more, so mass of steel will also be more for the same dimensions. Calculate the thermal capacity of the aluminium. Now, dear friends, the formula for thermal capacity is equal to mass times specific heat capacity. So mass of aluminium is 0.41 times the specific heat capacity of aluminium is 0.91. 0.41 times 0.91. So 0.373. So unit is this, we can write 0.37 joules per degree Celsius. Sorry. Why joules per degree Celsius? It is thermal capacity. And what is the definition? Heat energy needed to raise the temperature of a substance of 1 degree Celsius by 1 degree Celsius. We are not talking about the mass. And if it was specific heat capacity, then the unit is joules per kilogram per degree Celsius. The reason, because specific heat capacity is defined as the heat energy needed to increase the temperature of a substance of 1 kilogram per degree Celsius. And even if you don't remember any one of them, see, my dear friends, M times T. Unit of mass is kilogram. Unit of specific heat capacity, check it is written. That is joules per kilogram per degree Celsius. Kilogram is cancelled with kilogram. What is left behind? Joules per degree Celsius. So that's why unit for thermal capacity is joules per degree Celsius. Water is heated in the saucepan. The initial temperature of the water and the saucepan is 20 degrees Celsius. Let it be T1. Calculate the energy transfer needed to raise the temperature of steel saucepan to 100 degrees Celsius. That is T2. This is very simple. E is equal to MC delta T. MCAT. Mass of the steel is 1.2. T is equal to 0.5. For steel, specific heat capacity is 0.50 and change in temperature 100 minus 20. So 1.2 times 0.5 times 80. 48 joules. So energy equal to 48 joules. Why metals are better thermal conductors than non-metals? This is a simple question. Metals have free electrons who transfer thermal energy. Free electrons to transfer thermal energy. Next is question number 6. Describe an experiment to determine the speed of sound in air. State the operators you need, details of how to take measurements, and how to calculate the speed of sound in air. Okay. You may use the space below to draw a diagram as part of your answer. Right now, I'm not drawing the diagram. I'm just sharing with you the answer. Or we can draw the diagram like this is microphone 1. Here is microphone 2. This is connected to a timer here. This is also connected to the timer. And the distance between these two microphones is measured. Now, first of all, apparatus needed is microphones, timer like stopwatch, and measuring tape. As two wooden blocks are bent close to microphone number one, it converts sound energy to electrical energy. And the timer is turned on when the same sound when the same sound reaches to microphone number two, it also produces a pulse of current which turns off stopwatch. In this way, the time is measured. The distance between the microphone is measured by measuring tape and then speed is equal to simply distance over time. Like this, you can get the full credit of these 5 marks. Sound waves from a television are diffracted through the doorways. Light waves from a television are not diffracted through doorways. Suggest why light waves and sound waves behaves differently in this situation. You know, for diffraction to take place, the wavelength of the incident wave should be equal to the size of the gap. Now, size of the gap in the doorways is very small. And the wavelength of light waves is even small. So that's why for light wave, diffraction is not possible through the doorways. But the wavelength of the sound wave is approximately equal to the size of the doorways d. So that's why diffraction takes place. So I'm writing in shortcut that for sound wave, wavelength of the incident wave is nearly equal to d, size of the gap. So diffraction takes place. But for light wave, the wavelength of the incident light is not equal to, or I can say, is very, very small than size of the gap. So no diffraction. So no diffraction is taking place. So like this, you can answer this question by knowing the basics of the diffraction, which I have written for you people over here. Now, next question is, figure 7.1 shows a ray of green light emerging from one face of a glass prism. On figure 7.1, draw the path of the green light entering and passing through the prism. So what to do here, my dear friends? We cannot do anything without drawing the normal. So this one is the normal at the point of entry, at the point of entry of green light into the prism. So as the light is entering from less dense to a denser medium, so it should be bending towards the normal. So some like roughly you can use in the exam the ruler to do so. Light entering and passing through the prism. So up to here it is done. But even if it is outside the prism also, so again you need a normal. And it will be bending now away from the normal, because from denser to less dense it will speed up, so it will be bending away from the normal. So roughly I have drawn this diagram. Let's say the green light is monochromatic. State in terms of a wave property what is meant by monochromatic light. Monochromatic light, light of single frequency, property of waves, or you can say light of single wavelength. Now state the speed of light in air. Very common question. 3.0 times 10 to the power 8 meters per second. Wavelength of green light in air is S. So lambda is given. Calculate the frequency of the light. We know B is equal to F lambda. So make frequency as the subject of equation. So frequency is 3.0 times 10 raised to power 8 over 5.2 times 10 raised to power minus 7. So as we are simplifying it, we are getting the answer almost equal to 5.8 times 10 raised to power 15. Sorry, 14. So 5.8 times 10 raised to power 14 Hertz, Hz. 14 Hertz. The refractive index of green light is 1.52. Calculate the speed of green light in the glass. So these are formula questions. N is equal to C over V. N is for refractive index. C is for the speed of light in the air. And V will be the speed of light in glass. So making V as the subject of equation, C over N. So 3.0 times 10 raised to power 8 over 1.52. And the answer is approximately, it is 1.97 times 10 raised to power is 1.97 times 10 raised to power 8. So we can round it off to the 2.0 times 10 raised to power 8. But don't forget to write the unit, which is meters per second. Then, my dear friends, figure 8.1 shows two charged metal plates with a gap between them. The plates are parallel to each other. The top plate is negatively charged and the bottom plate is positively charged. On figure 8.1, draw 5 electric field lines between two plates. I'm doing it roughly, but you will be drawing them in exam with the help of a ruler. This is done. Now, this you will not be getting the 2 marks till you are not drawing the arrowhead. It is always drawn from positive towards negative. So the arrowheads will be pointing from positive towards negative. Now, an electric iron has a power of 2400 watt. Potential difference of the main supply is 220 volt. Calculate the electric current in the iron. Remember, my dear friends, that nowadays 70% plus, we are calculating the value of current by the formula of electrical power. P is equal to IV. Current will be equal to power over voltage. So I is equal to 2400 over 220. And as we are simplifying it, 2400 divided by 220. So 2400 divided by 220. 10.90. 10.9 amperes, or even you can use 11 amperes. Calculate the electric charge which flows through the iron in 15 minutes. So, current is rate of flow of charge, Q over T. So, making Q as the subject of equation I times T. So, I'm telling to remember it, IT, which means information technology. So, Q is equal to 10.9 times time, which is 15 minutes. But don't forget to convert these minutes into seconds. Times 15 equal to this times 60, that is 9818. So we can round it off to 9800 column because the unit of charge is 9800. Now, fuse ratings of 3 ampere, 5 ampere, 10 ampere, 30 ampere, and 30 ampere are available. State which of these fuse ratings is suitable for use in the iron. Let's see how much current is flowing through the iron. It is 11 ampere. So the rule is these fuse ratings are not useful. In 3 ampere, 5 ampere, and 10 ampere fuse ratings or fuses are not useful. 13 ampere and 30 ampere, then the next remaining options. We are always choosing the next higher value available. Even 30 ampere will not be making the circuit to be disconnected. But the problem is it will allow an extra current to flow, which can cause the overheating. So the rule is always whatever is the current flowing through the electrical appliance, you are supposed to choose a fuse with the very next value of the current available. Like in this case, 10.9 ampere current is flowing through the electric iron. So which fuse should be connected in series with the electric iron? It should be the next higher value available, and that is 13 ampere. Circuit breaker, fuse, and switch. They are always connected in circuit in series. It means there is only one path for the flow of current. Okay, my dear friends. Yeah, this is a very good question, by the way. Let's see it. Figure 9.1 shows current potential difference graphs for a resistor, a thermistor, and a filament lamp. The resistor, the thermistor, and the filament lamp are connected in series with a power supply. So draw a circuit diagram for this circuit. This is the symbol of a power supply. Don't use plus minus, that will be a cell or a battery. This is the symbol of a resistor. Then we are supposed to draw a thermistor. And then a lamp. So all are connected in series. Then add a voltmeter to your circuit diagram in AI in a correct position to measure the potential difference across the resistor. We know if we are supposed to measure the potential difference across resistors, so the voltmeter should be connected across the resistor. 1 mark. Use the graph in figure 9.1. Determine the potential difference across the terminals of the power supply when the potential difference across the resistor is 6 volt. Power supply. It means we need to know the total voltage or EMF of the power supply. So, as the components are connected in series, so as the component are connected in series, so EMF is equal to total voltage, that will be voltage across the resistor, plus voltage across thermistor, plus voltage across the lamp. So how we will calculate? Resistance across the resistance, it is already mentioned 6 volts plus, let's see, resistor. This is a resistor. So 6 volt, a straight line. We will see what is the current flowing through the resistor. Whatever the current is flowing through the resistor, same will be the current flowing through the lamp and thermistor. The reason they are all connected in series, there is only one path for the flow of current, and for the given resistances, current through every point in series circuit stays the same. So 0.4 ampere is the current flowing through resistor. Same current will be flowing through thermistor. So like this. But what is the voltage then across thermistor? 9 volts. So thermistor is done. What about filament lamp? So for the same current of 0.4 ampere, the voltage across or potential difference across the filament lamp is 3 volt. Across resistor, the J already is 6, and across thermistor, it is 9 volt. So they will be all added up together. So we will add these all potential differences together as they are connected in series. So 6 plus 9 plus 3, total is 18 volt. Practical use for a thermistor. Thermistor or LDR, these are sensing devices. used for for temperature control in electric kettle. There is a thermostat even in the incubator, even in this fan, mean thermostat in the AC, air conditioner. So many uses. Where temperature sensing is needed, so we can control the temperature with the help of this thermistor. Okay, dear friend. Then the next question is on transformers. A transformer has 500 turns on its primary, so NP, and 25 turns on its secondary, NS. The input voltage, in other words, primary voltage is 120. Calculate the output voltage. It means Vs we need to find. So Vs over Vp, the voltage ratio is equal to turns ratio, Ns over Np. Let's make Vs as the subject of equation, Ns over Np times Vp. All the values are with us. So Ns, number of turns on secondary, 25, voltage in primary, 120, across primary, 120, and number of turns on primary are 500. So as we simplify this, the answer comes to be 6 volts. V capital. The current in the primary is 150 milliampere. So that is IP. Transformer is 100% efficient. Output current we need to calculate, IS. So we can use, when the transformer is 100% efficient, or the condition is there is no energy loss in the transformer, then input power is equal to output power. Vp times Ip, which is input power, equal to Vs times Is, which is output power. So dear friends, Is is equal to Vp, Ip over Vs. Let's place the numerical values. Is is equal to Vp, which is 120 times Ip. Be very careful, 120 times 10 raised to power minus 3, because milliampere. 125 times 10 raised to power minus 3 over Vs, which is 6 volts. As we are simplifying it, answer comes to be 2.5. So it will be 2.5, and don't forget to write amperes. Figure 10.1 shows a loose wire connected in a circuit with a DC direct current, a current that keeps on flowing in the same direction, power supply and a switch. The length of the wire between the two supports, these are the supports in the magnetic field of a horseshoe magnet. The power supply is switched on and the wire moves down. On figure, draw an arrow on the wire to show the direction of the current. To get the direction of the current, we are going to use Fleming's left-hand rule, which says that if we stretch the forefinger, middle finger, and the thumb of the left hand such that they are perpendicular, to each other this way, then middle finger, it points towards the magnetic field. Forefinger, points towards the magnetic field. Middle finger points towards the conventional current, and the thumb points towards the force direction of motion. I'm telling the students to memorize it. Father, mother, child. Force, magnetic field for the M for mother, and child C for conventional current. Now, if I'm making this north to south, the field finger, then current. As the wire is moving downward, so this thumb will be pointing down. It will be like this. See, current finger is going from right towards left. So it means the arrow will be pointing this way. So using Fleming's left hand rule, see the magnetic field M here, wire is moving down according to the examiner. So force here and then current will be pointed towards left. In other words, from right towards left. Okay, my dear friends. Then next is the power supply is switched off and the wire returns to its original position. No more force is acting on it. The power supply is then switched on so that the current is in the opposite direction. Still explain what happens to the wire. See, before the wire moves down, now wire will move upwards. Why? As the current is reversed, current is reversed, the direction of magnetic force, I'm writing just force, is also reversed. A split ring commutator is an important feature of a DC motor. This is a recall memory formula answer question actually suggests one reason why the DC motor cannot operate without a split ring commutator. So in the absence of commutator, the coil will not be able to rotate in same direction. So that's why a split ring commutator is needed. Okay, my dear friends. Next question is now on nuclear physics. A detector of radioactivity is placed in a laboratory where there are no radioactive samples. A student notices that the detector shows a count rate that varies between 20 counts per minute and 24 counts per minute. So no radioactive samples are there, and these values are not very high. So this all leads towards background radiations. Suggest a source for these readings. So that can be the logs in the walls of the room, of the laboratory, or the radon gas in the lab. So source of these readings, source of these readings is background radiations. Why these readings are not constant? Very simple answer again. Many times it is repeated. Whenever there is a minor difference in the values continuously, it is because radioactivity is a random phenomenon. So radioactivity is random process. A radioactive decay is a random process. A nucleus of uranium contains 92 protons and 146 neutrons. It decays by emitting an alpha particle to become a nucleus of thorium. Complete the nuclide equation for this radioactive decay. These are the free marks, by the way. Number of protons, 92 for uranium. Neutrons are 146. So 146 plus 92, 238. Alpha, helium nucleus. So proton number should be same on both sides of this equation. 90. Now 92 for uranium, 90 plus 2, it is also equal to 92. So the proton numbers on both sides of the decay are the arrow same. 238 minus 4, 234. So now 238 is the nuclear number of uranium, and the sum of nucleons for thorium and alpha is also 238. So this equation is okay in terms of nuclear number also. Nuclear number is also conserved. Next, an isotope of radon has a half-life of 3.8 days. It decays by emitting alpha particles, alpha radiations. Calculate the time taken for 16 milligram of this isotope to decay to 2 milligram of the isotope. So we know after in every half-life, half of the mass is reduced. Half of the mass of the original value is reduced. First of all, let's calculate how many half-lives are involved to change the mass from 16 milligram to 2 milligram. Sixteen divided by 2, 1 half-life. Answer comes to be 8. We need to go to 2. So 8 divided by 2 equal to 4, second half-life. 4 divided by 2 equal to 2. This is something which we need to reach. So how many half-lives? 3 half-lives are gone. So time will be equal to 3 times the time for 1 half-life, which is 3.8 days. So 3 times 3.8, 11.4 days. So that is the time taken for 16 milligram of radon gas to reduce to 2 milligram. So if we are rounding it off, so easily we can write 11 days as the answer. So in this way, my dear friend, this paper is completed. And by the way, in this paper, I think 43 out of 80 was 80 mark, was A grade. I think so, 43 out of 80. So almost 51.2% is needed to score A in this paper. I am hopeful that this recording or this explanation for the paper will be useful for you. So stay blessed. Wish you all best of luck. And don't forget to follow, like, and share this channel to your dear ones and the world, and especially those students who are going to take the externals in May, June 2025 or October, November 2025. And if you have not subscribed this channel, so don't forget to subscribe it so that you can get the new videos which I will keep on uploading on these past papers. And in the coming week ahead of us, the two major blocks, paper 4, for paper 4, paper 2, and paper 6 for all papers, two major blocks. The general physics explanation in shortcut I will be sharing with you in a recording of 1 hour, few minutes. And also block 4, electricity and magnetism will be explained. So stay tuned, keep on working hard. Take care. Bye.